Hello everyone, in this lesson we're going to talk about the differences between the alternating current and the direct current. And by the end of this video, you understand why we have these two types of currents. Okay, so first, what are the differences, right? So for the direct current, this type of current is the flow of electric charge in only one direction, okay? You can think as the steady state of a constant voltage circuit, right? So the voltage and the current in the DC current are constant over time, all right? And for the alternating current, AC, is the flow of electric charge that periodically reverses direction. So it keeps going to one direction and going back, okay? So for this case here, the voltage and the current assume this wave form, okay? So it changes, it varies over time. And well, that's also one of the inspirations for the rock band AC/DC, right? Okay, so let's start with the direct current here. Well, we know that the voltage and current are constant over time. And for this type of a simple circuit, okay, with one resistance, we can apply just the Ohm's law, right? V equals R times I, and for the power equals the current times the voltage, okay? If you have doubts about how to apply Ohm's law, you can check our video on Ohm's law. Alright, so now let's go to the alternating current, the AC circuit. Okay, let's assume a simple circuit with one resistance, and that's what happens with the voltage. Okay, see that it varies in a wave format. Okay, so that's a sine function actually. And we have two peaks. We have positive V0 and negative V0. All right. So for the voltage, we can calculate the instantaneous voltage using this formula here. That's actually the sine formula, okay, times the peak voltage. And for the current, that's exactly the same, okay? We have I0, the peak current, that we can calculate using Ohm's law also, all right? And we have this term here. Alright, this term is what we call the phase. So remember, the voltage and current assume this format, okay, this waveform, and we have peaks. But, well, in a circuit, we can, these two peaks, the voltage and current can match at the same, they can happen at the same time, okay? But sometimes it can happen in different times, alright? So the peaks, for this example here, it's happening in different times. So this difference in the time of peaks is the phase, right? Well, we're dealing with waves here, so it's reasonable to talk about frequencies. So that's exactly why we talk about frequencies in our circuit and distribution systems. All around the world, generally for AC currents, we use 50 Hertz to 60 Hertz, okay? And you can think this frequency as how fast a light bulb, like a fluorescent light bulb, flashes. It's like 50 times per second or 60 times per second, right? We cannot see the light flashing because it's too fast, so we cannot perceive it, but it's actually flashing in this frequency, right? So we calculate the voltage, the current. We can also calculate the power for an AC circuit, okay? Well, the instantaneous power is actually the multiplication, right, of the current times the voltage. So that's exactly what we have here. So we're just multiplying the two functions, okay? But when we're dealing with power, we actually don't use this formula that much, all right? We can just take the average power that's in the middle here, right? We have an average power, and we can calculate it using the average voltage and the average current of the circuit, all right? And this average here, remember, you can calculate using the RMS, the root mean square of the current and of the voltage, which is the peak divided by the square root of 2, okay? And remember, we also take into account the phase here, the phase difference, all right? Another important thing to calculate sometimes is the power that's dissipated in a circuit, which is the current, the RMS current squared times the resistance. Well, so why we use this, like when do we use the AC current, right? One of the most common applications is for distribution, and we use AC currents basically because it's easier to increase and decrease the voltage, all right? It's much easier than the DC current. So generally you use DC currents for transmitting energy, right? And AC currents, AC circuits, in order to distribute this electricity. So these are the electricity, like the energy we have in our houses. Mostly they are all AC currents, okay? All right, so let's do some calculations here so you can understand it better. So let's answer these questions here. So what current is needed to transmit 100 megawatt of power at 200 kilovolts? Well, we're dealing with AC currents, okay? So these values here are actually RMS values, all right? They are the mean values. So you can simply apply the power formula, right, to calculate the current, okay? And the average current, the mean current, is actually 500 amperes. And well, okay, so what's the power now that's dissipated by the transmission lines if they have a resistance of 1 ohm? Again, these are mean values. We can just use the power dissipated formula, all right? And see that the power dissipated is 250 kilowatts. So what is this percentage of loss, right? We're using 100 megawatts and we're dissipating 250 kilowatts. So what is the percentage of the power that is lost in these transmission lines? You can just divide one to the other one, all right? Dissipated over the needed. And we know that the percentage of loss is very low, right? 0.25%, less than 1%. It's a quarter of a percent. So it's actually acceptable. Note that we're using 200 kilovolts. It's a very, very high voltage, right? And there's a reason for it. And that's what I want you to think about, okay? So what it would be the percentage loss if the same amount of power was transmitted at a lower voltage? Instead of 250, just 50 kilovolts, okay? Do your calculations and justify why we use such high voltages in transmissions, all right? Okay, so I want you to answer it in the comment sections, and I'll see you next time.
Thanks for watching. Don't forget to subscribe and turn on notifications to always get the newest videos straight to your feed.